So we got a trying to get on the video. All right, we got this balloon. So we'll do a circle. Okay, it's a buoyancy. Buoyancy is a force problem. Force problems always begin with free body diagrams. So here's the balloon. It's a weather balloon. What are the forces acting on the weather balloon? Well, two of them are mentioned up here. So we have 600 kilogram weather balloon. That's actually the balloon itself, you know, the material the balloon's made of. And it's designed to lift a 4,000 kilogram package. We'll put like a package down here. Here's the package. What volume should the balloon have after being inflated with helium at standard temperature and pressure? Standard temperature and pressure, that just affects the density. You know, as temperature goes up, air becomes what, more dense or less dense? Less dense. So STP, you know, that's just giving you these densities here. The density at standard temperature and pressure. You got to look these up. On the quiz, I'll give you densities. You don't have to memorize them. All right, so what are the forces on this balloon? Well, let's do these two first. So we have mg down for the balloon itself. So we'll put mb, so that's the weight of the balloon right here, 600 kilograms. Ba-bam. Okay, it's lifting a 4,000 kilogram package. So which way is the package pulling on the balloon? Is the package pushing the balloon up or pulling it down? Down. So put that down. This is going to be, we'll put mass of package times gravity, the weight of the package. And then there's a third force pulling the balloon down. What's the third one? The helium. Which I know is weird because people think, oh, helium, that's up. Well, I mean, if you filled the balloon with water, which way would you put mg for water? You'd put it down, right? So the fluid going into the balloon is helium, so that's going to be mass of helium times gravity, mg for the helium. So we have three down forces, and then what's the up force? The buoyant force. Okay, what does buoyant force always equal? The weight of the displaced fluid. And in this case here, now the problem doesn't explicitly say it, but it's safe to assume that this is in air. So this is going to be mass of air times gravity. Buoyant force always equals the weight of the displaced fluid. Okay, so now what's the next step? After free body diagram, we sum forces. Okay, so we have the up force is the weight of the air displaced, mass of air times gravity, and then we got the three down forces. So we got weight of the helium, we got the weight of the package, we got the weight of the balloon itself. Okay, and then sum of the forces always equals ma, where this m would be the mass total. You know, let's see, so it's pulling a package up. So you'd include the mass of the package there, right? It's kind of like this whole thing would become one object because they're connected together. So you would do package, helium, balloon, everything, okay? But is this balloon accelerating? No, because the way they word this, in order that the load can be lifted. So it's kind of like the balloon is going to barely lift the package off the ground, you know. Not accelerate, just lift the package off the ground. So we can set the acceleration to 0 because we don't want this to be accelerating. And then what we're left with is this. Okay, now what are we missing? Fluids are tedious. You got to solve for a lot of things. So what are we missing in this problem? We don't have what? Mass of the air or mass of the helium. We don't have those, right? But what can we plug in? Density equals what? Density is mass over volume. So mass is density times volume. You can take that, plug it in there, okay? So, oh, and by the way, all the G's are going to cancel. The G's are going to drop out. The G's cancel out. So plugging this in, we're going to have density of air, volume of air, minus density of helium, volume of helium. I just plugged that in, equals mass of package plus mass of balloon. I just took these guys and I moved them across the equal sign. Okay? Now, what do we know about these two volumes? Volume of air and volume of helium. Are they the same volume or different volume? They're the same. Because look, what's the volume of the helium? The volume of the helium is the volume of the helium inside this balloon, right? And then what do we mean by volume of air? It's the volume of the air that is displaced. Well, how much air got displaced? Whatever the volume of the balloon is. So these two volumes are equal. These two volumes here are equal. So factor the V out. The volumes are the same. Those are the same. So V, density of air minus density of helium equals mass of package plus mass of balloon. Okay, so volume is going to be mass of package plus mass of balloon divided by density of air minus density of helium. So this comes out as, so this is the numerator, that's going to be 4,600 kilograms. And then density of air, 1.29 kilogram per cubic meter. Density of helium, 0.179. Right? So then the answer is 4,140 cubic meters. That's a big balloon. Real big. Any questions on this? It all starts with the free body diagram. You do free body diagram, identify all the forces on the balloon, sum them up, substitute in the density equation, solve for volume.